particular node is called the root node, and these are the children's. Okay, so this is a tree data structure. This particular figure denotes a tree. This tree has one root node and two children. Okay, now for a what is a binary tree? This is a binary tree because each node each node here, the root node, suppose uh, this is a binary tree. Why this is a binary tree? Because binary tree consists of every node in a binary tree has maximum two children. It may have either 0, 1 or maximum two children. Okay, now here this particular node has two children, this one and this one. Okay, this node has two children, this and this, but this one has only one children. This is the last node. Okay, so that's why this is a binary tree. This is a ternary tree. Why this is a ternary tree? Because every node has maximum three children. That's why this is a ternary node. Okay, now we have to study about the binary tree. What is the height of a tree? Let this is a binary tree. This is a binary tree. Why this is a binary tree? Any idea? Anyone?
Each node has maximum of two children.
Okay. So first, this is a root. So we can denote the root as level 0. Okay. Next, this is the next level. So level 1. Next, this is your level 2. This is the level 3. This is your level 4. And these are the leaf nodes level 5. Okay. Now height of the, you have to find out the height of the tree. H is the height of the tree. What will be the height? Height means the number of branches starting from root to the farthest leaf is called the height. Okay, so what will be the height? It is the number of branches starting from the root. This is your root node. This is your root. Okay, root node. All the branches are coming out from this root node. You have to find out the number of branches, maximum number of branches starting from the root node to the farthest leaf. This is one leaf. Okay, this is one leaf node. Because why this is a leaf node? The nodes that have no outgoing edges, branches, these are called the leaf nodes. Okay, so this is another leaf node. Okay, and these are two leaf nodes. Now you have to find out the height of the tree. What will be the height?
Five.
Because you have to go to the farthest leaf. So you have to scan this line, next these two, next this is 3, 4 and 5. Or you can take also this one, 5. So here the height is 5. So what is height? Height is the distance, height is the distance, or simply you can count the number of branches, okay, starting from the root to the farthest leaf. So this is the height, right? Now, now there is a lemma. What do you mean by lemma? Any idea? What is theorem? Do you know what is theorem? Anyone?
Theorem is kind of like a formula that is proved.
And what is lemma?
I don't know.
Lemma is a small portion of the theorem. You can imagine that a theorem may consist of several lemmas. Lemma can be also proved, but in a smaller uh, version of the theorem. Okay, so let one lemma is that, is it visible?
Yes, sir.
Yes, sir.
So for
Yes, sir.
any non-empty, for any non-empty binary tree, so for any non-empty binary tree, capital T, okay, so you can denote this tree as capital T. If if n0 is the uh, number of leaf nodes, and n2 is the number of uh, nodes with degree 2, degree 2, uh, then n0 is equal to n0 is equal to n2 plus 1. You have to prove this. Okay, so what is the degree of a node? We have to know what is the degree of a node. Degree of a node means the number of branches or number of nodes that are connected to a particular node is called the degree of a node. Okay, so what will be the degree of the root node here?
2.
2. Why? Because two nodes are connected with the root node. So what is the degree of this particular node that are
1.
at level 3? 1.
1.
Because only this node is connected with the node resides at level 3. Okay. Now degree of a tree means degree of the highest node, that is the degree of the whole tree. So here the highest degree, what is the highest degree here? Here this root node has the highest degree 2. This particular node has degree 2. Okay, this particular node has the degree 2. That's why, as this is the binary tree, and here we can observe that every node, some nodes, moreover some nodes will have degree 2. That's why the whole degree of the tree is 2. Okay, now we have to prove this lemma. So how to prove this lemma? uh, any idea? Anyone? Lemma 1. Can you guess? Anyone?
No, sir.
So if n is the if n is the number of nodes, if n is the number of nodes in your tree capital T, that capital tree is a non-empty binary tree. Okay, it is given, and it is also given that n0 is the number of nodes with no children. That is, n0 is your leaf nodes. We know that leaf node has no children, right? N2 is the node. What do you mean by N2? N2 is the node with exactly two childrens, and N1 is the node with one children, right? So total number of nodes in your tree can be written as N0, as this is the binary tree. So we know that binary tree means you have either 0 or 1 or maximum two number of nodes associated with each node. Okay, so n0 plus n1 plus n2, is it true? The total number of nodes,
Yes,
is
sir.
it true?
Yes, sir.
For a binary tree, for a non-empty binary tree, total number of nodes is equal to nodes with no children, nodes with exactly one children, nodes with exactly two children. So this is equation number 1, right? Now we can write branch B. We can write branch B is equal to n1 plus 2 into n2. This is equation number 2. Okay, this is our equation number 2. How can I write this? Branch is equal to n1 plus 2n2. Any idea?
Sir, obviously the ones with zero children won't have any branches. So, and
So,
the ones with
so,
two,
so, so in so uh, we can deduce the B from actually this one. I'm writing this n0 plus n1 plus n2 plus n2. Okay. So n0 branch means these are the branches. These are the branches. This one branch, this one another branch, this one branch, this one another branch. Okay, so branch can be written in this form. So n0, what do you mean by n0? N0 is the number of nodes that have no branches. Okay, these are the leaf nodes, right? So 0 into n0, can I write this? No branches are coming out from the n0 node. Is it clear to you? Because n0 is the leaf nodes. Okay. Now for n1, n1, what do you mean by n1? N1 is the number of nodes with exactly one children. So how many branches are associated with the n1 nodes? Any idea? Any
one.
idea? One. Because one node is connected to n1, that's why one branch is connected to n1. Now n2 means number of nodes with exactly two children. So 2 into n2. So 2 into n2. So combining these two we can get, so this will lead to 0, and we can get n1 plus 2 n2. Is it clear? Is
Yes,
it
sir.
clear to you?
Yes, sir.
So this is our equation number 2. Okay. Now again we can write n is equal to b plus 1. Can I write that? N is equal to b plus 1. Total number of nodes is equal to your number of branches plus 1. Is it true? Because suppose this is the simplest form. of a binary tree. Okay. So here number of branches b is equal to here b is equal to 2 and n is equal to here 3. N is equal to 3. So that's why n is equal to b plus 1. This is another formula. So you can write this. So equation number 1, 2 and 3. Is it clear to you?
Yes,
Yes,
sir.
sir.
So
Yes, sir.
so from equation number 1 we can write b plus 1 is equal to n0 n0 plus n1 n0 plus n1 plus n2. Okay. Next, b means, what do you mean by b? Substitute the value of b. So n1 plus 2n2, n1 plus 2n2 plus 1 is equal to n0 plus n1, n0 plus n1 plus n2. So finally n1 and n1 cancels out and we can get the formula n0 is equal to, here n0 is equal to n2 plus 1. Is it clear? So
Yes, sir.
this is the lemma. This is one of the most important theorem or lemma. Okay, one of the most important theorem. Okay. Now can you find out the maximum number of nodes? Can you find out, just 1 second, lemma 2, lemma 2, the maximum number of nodes, number of nodes, maximum number of nodes on level I of a binary tree is 2 to the power I minus 1. 2 to the power I minus 1. This is 2 to the power I minus 1. How can I prove this? Anyone? Where it is given that I is greater than is equal to 1. So here the level starts from 1. Any idea? Anyone? Maximum number of nodes on level I in a binary tree is this. How can I prove this? Anyone?
Sir, can we do something from the branch thing?
It can be.
Sir, like, can we use the branch formula here?
Why not?
Sure.
So that this is a binary tree. So here it is given that you have to start the level from 1. So this is level 1 This is your level 2, and this is your level 3. Okay, so at the first level, how many nodes are there?
One.
The lemma is maximum number of nodes on level I in a binary tree, let capital T, is 2 to the power I minus 1 if this is valid only for if and only if. I double if means if and only if I greater than is equal to 1. I greater than is equal to 1. So here, uh, at the first level, how many nodes are there? 1. Why 1? 2 to the power 2 to the power I minus 1. So 1 minus 1 at the first level. This is the level 1. Here it is given that you have to start from level 1, not 0. Okay. So 1 minus 1. So 2 to the power 0, that is 1. So at the second step, here the value of I is 2. So 2 minus 1. 2 minus 1 means 1. 2 to the power 1 means 2. This is the level 3. So 2 to the power 3, 2 to the power 3 minus 1, that is 2 to the power 2, that is 4. Is it clear? So the
Yes, sir.
maximum number of nodes at level I is equal to 2 to the power I minus 1. If and only if, that is I double F, if I is greater than is equal to 1. Suppose I is starting from 0, just like this one. Actually, this is the notation for Coreman. Coreman follows this notation. Starting Coreman, D. Shamanto follows this notation, starting from 0. But Horoit Shahani, I think Lipsus, these books follows this notation starting from level 1. Let this is level 0, this is level 1, this is level 2. Starting from level 0. Then can you modify the lemma? Anyone? If the level starts from 1, if the level starts from 1, then maximum number of nodes at level I can be written in this
You
form,
are right.
2 to the power I minus 1, if it starts from 1, level 1. But if it starts from level 0, then how can you modify your
You are right.
lemma? 2 to
You
the
are
power
right.
I. 2 to the power I. Okay, so you can also modify this one. Just 1 second. 2 to the power I. These are very important theorems or lemmas. Actually, these uh, these two forms are very important for your exam purpose. Either you can give that you are given that I is greater than is equal to 1, then the formula is 2 to the power I minus 1. Otherwise, if I is greater than is equal to 0, then the formula is 2 to the power 0. Is it clear? Then
Yes, sir.
lemma 3.
So there's no proof.
Sorry.
There's no proof for lemma 2.
You can use the induction, mathematical induction. Mathematical induction. By mathematical induction, you can prove this. Can you do that by mathematical induction, or should I explain?
I guess we can do that. If
Please be louder.
we can be sure if you complete it.
Okay. Uh, let the what is the first step? Uh, Induction base. So first step is your induction base. What is the induction base? This is the base case. Okay. So at the base case, that is your very starting step. What will be the value of I at the base case? What will be the value of I?
One.
1. So at the base case, I is equal to 1. So 2 to the power I minus 1. 2 to the power I minus 1 means here 2 to the power I minus 1 means 2 to the power 0. That is 1. So only one node can be there in the level I is equal to 1. So at the first level, there will be only one node. This is the root node. Okay. So base case is proved. Next one, induction hypothesis. So induction base. Next one is the induction hypothesis. So induction hypothesis, let I be an arbitrary positive integer which is greater than is equal to 1. It is given that I is greater than is equal to 1. Okay. I is greater than is equal to 1. Now we assume that the maximum number of node in level I minus 1, just assumption, at I minus 1, the maximum number of nodes is 2 to the power I minus 2. It is our assumption. Okay. Now induction step. Induction step. So induction step, the maximum number here, the maximum number of nodes at level I minus 1. Level I minus 1 is 2 to the power I minus 2, maximum number of nodes. It is our assumption from induction hypothesis. Okay. Now each node in a binary tree, each node in a binary tree has a maximum degree of what? Each node in a binary tree, it has a maximum degree. What is the maximum degree of a binary tree?
Two.
Not getting the answer?
Two.
Yes. So the degree, each node in a binary tree has the degree, maximum degree is 2. Okay. So the maximum number of nodes on level I minus 1. So the maximum number of nodes on level I minus 1 is just a power of 2. It is just a power of 2. So not 2 to the power I minus 2. It will be 2 to the power I minus 1. So our assumption was incorrect. So the maximum, as each node in the binary tree has a maximum degree, it has a maximum degree of 2. The maximum number of nodes on level I is 2 times the maximum number of nodes on level I minus 1. So we can get 2 to the power I minus 1. So 2 to the power I minus 2 was our wrong assumption. Is it clear? You can use the mathematical induction or you can use any other form. The mathematical induction proof is clear to you or not?
Yes, sir.
Yes, sir.
So next lemma, the maximum number of nodes. Maximum number of nodes. The maximum number of nodes. Just 1 second. Hold just 1 second. The maximum number of nodes uh, in a binary tree of height or depth depth h depth h is 2 to the power h minus 1 or 2 to the power oh 2 to the power h minus 1. The maximum number of nodes in a binary tree of height or depth height h is 2 to the power h minus 1. Can you do that? Any idea?
So this will also be proved using induction, I think.
Uh, in
So here also we will have to use induction, I think.
okay. So we can say that maximum it is given that maximum number of nodes in a binary tree of height h is 2 to the power h minus 1. Okay. So if n is the total number of nodes, if n is the total number of nodes in the tree, then we can say that then we can say that 2 to the power uh, we can say that 2 to the power I, where I starts from 0, where I starts from 0. Can we write that?
Not a mind.
This will be this. Or you can write, if you follow the level starts from 1, if you follow the level starts from 1, then I is equal to 1. I is equal to 1 to h, I is equal to 1 to h, and 2 to the power I minus 1. Is it clear? Is it clear to you?
Yes,
Yes,
sir.
sir.
So if sorry, if it's if it starts from I is equal to 0, if it starts from I is equal to 0, then we can write this one. Or if it starts from I is equal to 1 to h, then we can write 2 to the power I minus 1. Actually, height and depth are same. So this is just a uh, series. If you solve the series, you can get 2 to the power h, 2 to the power h minus 1. What is the series? Anyone? What what type of series it is? How can you solve this? In the exam, you have to solve this series. Anyone? Shourashish? GP. Shotish GP, correct. 9036 Shotish. Yes, this is the GP series. You have to solve the GP series and you will get 2 to the power, actually 2 to the power h minus 1 divided by 2 minus 1. A into r to the power, a into r to the power, a into r to the power n minus 1 by r minus 1. Common factor r is equal to 2. Okay. So 2 minus 1, this is 1. 2 to the power h minus 1. Is it clear? Is it clear to you?
Yes, sir.
Yes, sir.
Okay. So I'm just stopping this class.